Let's look at graphing y equals 4 plus the sine of x. As I look at this equation and how it's different from the parent function of y equals sine of x, I notice there's only one difference, and that's adding 4. The 4 is added out front. It could be added at the end. The important thing is not added with the function itself. So what this does to our graph is it shifts up by 4. Our process is, first of all, we want to draw in and label our horizontal axis. The period for this one is 2 pi divided by b. In other words, the period is 2 pi. So we'll put 2 pi, 4 pi. We'll mark our different points in that interval. So it'll be pi, 2, 3 pi over 2, 5 pi over 2, 3 pi, and 7 pi over 2. And on the y-axis, things will be a little bit different. Our amplitude is 1 because the sine of x is multiplied by 1, but because it shifts up by 4, that means our horizontal axis, our line of equilibrium, we call that, is shifted up by 4. And with an amplitude of 1, that means our maximum is 5 and our minimum is 3. So here is how we're going to use that shift up by 4. Now the problem is like what we've had before. It is a sine curve. Sine starts at 0. The first period ends at 0. It goes up and then down. Second period is going to end at the middle again. So I have my points then to draw in this curve. It's going to look like this. So there is my sine curve shifted up by 4. Next example. Now this one has quite a bit more going on. Because of the minus 1 up front, it's shifted down by 1. Because of the 3, I know the amplitude is equal to 3. And then the 1/2, well, 2 pi divided by b is the period, multiplied by 2, multiplied by 2, so the period is 5. Now that preliminary work out of the way, we can go through our normal process. The period is 4 pi, so there's the end of the first period. There's the end of the second period. We'll mark off our different locations, 1 pi, 2 pi, 3 pi, and in the next period, 5, 6, 7, and 8 pi. Now at this point, I want you to think about how the -1 is going to impact the graph, and then the fact that the amplitude is 3. Because it's down by 1, means our line of equilibrium, this horizontal axis, is at -1. With the amplitude of 3, we go up 1, 2, 3. That means our maximum value is 2. We go down by 3, and our minimum value is -4. So everything is set up. It is a sine curve. So sine starts in the middle, ends in the middle, and it goes up first. For the second period, it's going to end in the middle. I'll hit all these various points. And then to finish it off, draw in the smooth curve. So a tough problem because there's all those different variations, but think about it step by step. It goes down by 1, the amplitude is 3, the period is 4 pi. Set everything up before you worry about drawing anything or plotting points. Set up your x-axis, your y-axis with the shift and with the amplitude, and then draw in your curve. Right. I would pause the video at this point and see what you can do. Unpause it when you're ready to go through the answer, or if you want to verify that something is correct. But see if what you can do with this one. Okay. Amplitude is 2 because of the absolute value of that. However, it is to reflect across the x-axis. We'll get to that in a minute. And then the period is equal to 2 pi divided by 1/4. Normally, I really don't like fractions. The fact that 2 pi is divided by 1/4 really means that 2 pi is multiplied by 4, so our period is a nice number of 8 pi. Here is my horizontal axis. The period is 8 pi, so this is 8 pi. Second period will end at 16 pi. get these different markings on our x-axis. Each one of these little marks represents 2 pi. Great. And now let's see, up by 5. So our line of equilibrium is up here, by more space up in that first quadrant. The amplitude is 2, so it reaches a maximum of 7 and a minimum of 3. And let's see, the reflection across the x-axis for cosine. Normally, cosine starts at the maximum and goes down, but because of the negative, it's reflecting across the x-axis. And maybe that's not the right way to say it. Maybe I should say it's reflecting across this line of equilibrium. So our cosine curve is actually going to start right there. At the end of the first period, it'll be back down there again. So figure out these in-between points. The second period, the same idea to it. Now, if we want to connect these points, it's going to look like that. There is our negative cosine curve, shifted up by 5 with an amplitude of 2 and a period of 8 pi. All right, next one. For the first time, we have some kind of function inside of the trig function. This is going to shift it to the side. First, it's not shifted up or down. There's no number in front of the x, so the period is going to be pi. But more important is the x minus pi over 2 and how that's going to affect the horizontal shift. What I'm going to say is that minus pi over 2 equals solve that, and I get pi over 2. So this is where the first period begins. Then I'm going to set x minus pi over 2 equal to 2 pi because that's normally where a cosine first period would end for the parent function. If you add pi over 2 to both sides, we get x equals 5 pi over 2. So this is where the first period ends and the second period begins. One more time, this time I'm going to set it equal to 4 pi, because that's normally where the second period would end. Add pi over 2 to both sides, and we get 9 pi over 2. That's it. That's everything we need to start getting our graph ready to go. So on the x-axis, that's always the first thing we're going to do. X starts at pi over 2. So I'm going to say, here's my distance of pi over 2. This is where my first period is going to begin. Just go ahead and put a little highlighted line there. The first period ends at 5 pi over 2. And the second period ends at 9 pi over 2. We go back to the first period, and halfway between 1 pi over 2 and 5 pi over 2 would be 3 pi over 2. Not bad. Halfway between 1 pi over 2 and 3 pi over 2 would be 2 pi over 2, which is just pi. Now let's figure out all these values. 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, 5 pi over 2, 6 pi over 2, 7 pi over 2, 8 pi over 2, and then 9 pi over 2. Amplitude is 3, so I can go to the y-axis, height of 3, and a minimum value of -3. Go to the points. It is a cosine curve. It's not reflected across any horizontal axis. The line of equilibrium didn't shift up at all, so it's cosine starting here. First period ends up there. So here are my points for the first period. For the second period, put them back on there as well. And then so our graph, it's a smooth curve connecting those points together. And there it is. So instead of starting at x equals 0, the whole graph just shifted to the right, and here's what our graph is going to look like this time. I've got one more example. The last two examples, I already have QR codes. You can scan and go through those. These have a lot going on, but piece by piece, look what happens, and you can figure those out. But let me come back to this one, and let's figure out what this graph is going to look like. The -2 up means the amplitude is 2. It is reflected across the axis. And because this isn't shifted up or down at all, the line of equilibrium is still the x-axis, so it is reflecting across the x-axis this time. The period is just 2 pi because there's nothing in front of the x, but we're going to set that equal to 0 to figure out where the first period begins, -pi. We'll set x plus pi equals 2 pi, subtract pi from both sides. Here's where the first period ends. And then we'll set it equal to 4 pi, subtract pi from each side, x equals 3 pi. Here's where the second period ends. So in this graph, for the first time, I'm going to leave more room to the left because my first period starting at negative pi. It's going to end at positive pi. I want to try to keep that spacing so those distances are the same. And then 3 pi. In the first period, I'll go ahead and use my highlighter again. Zeros in the middle. This would be negative pi over 2, positive pi over 2. In the second period, so negative 1, or negative 2 pi over 2, negative 1 pi over 2, 0, 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, 5 pi over 2, and there's 6 pi over 2. This is a negative sine curve. Sine always starts in the middle, ends in the middle, but because of the negative, it actually goes down first. My amplitude is 2, so there's up 2, down 2. All right, so then it goes down and then up, back down. We're going to figure out the middle points. So this one's going to go down and then back up, giving us a graph that looks like that.